Hi guys, welcome to a new video on differentiation under Math SL. In this video we shall tackle questions that require the use of limits in differentiation. We shall solve the two questions on the screen in front of you, and I shall begin question 1 shortly. So question 1 came in paper 1 May 2000, question number 15. Kindly take a minute and attempt to solve, and the answer shall follow through shortly. So you are given f of x equals x cubed, rewritten in black right there, and you are asked in question A to evaluate f of 5 plus h minus f of 5 over h. So here, since the function is x to the power of 3, I need to replace the x with 5 plus h and evaluate that, then replace the x with 5 and evaluate that, and then combine all of these together to evaluate the entire fraction. So first let's get f of 5 plus h. Let's evaluate that separately. This shall be obtained by replacing the x with 5 plus h. So we need to find 5 plus h all to the power of 3. This is evaluated as 5 cubed plus 3 times 5 squared times h plus 3 times 5 times h squared plus h cubed. Similarly, f of 5 is obtained by replacing the x with 5, so this gives us 5 cubed. We compile all of these into the fraction that we want to evaluate, so we get f of 5 plus h minus f of 5 over h as equaling to this blue expression right there, which was simply obtained by simplifying the gold expression and adding the green expression to the numerator right there. As for h in the denominator, this remains as it is. So the rest is just algebraic simplification. I've combined the like terms, and then I've factorized. I've taken out h as a common factor from the numerator. So 75h became 75, 15h squared became 15h, and h cubed became h squared because I took out an h, which is a common factor in all of the terms in the numerator. Next, you cross out the h in the numerator with the h in the denominator, hence reaching this final blue expression. So you want to evaluate this expression for h equals 0.1, so you just substitute 0.1 instead of h, getting this red expression right there, which simplifies to 76.51. So in question B, you are asked what number does the expression approach as h approaches 0. So you're just going to plug 0 instead of h again in this blue expression, and you realize that the expression approaches 75 as h approaches 0. Of course, here this is a very simple question. Next, in question 2, we are going to see a more complicated example of limits. So pause to copy this down if you will, and I shall begin question 2 shortly. So the second question that we shall solve came in paper 2 May 2009, time zone 1, question 10. Kindly take a minute, attempt to solve, and the answer shall follow through shortly. So question A requires us to expand x plus h all cubed. Let's take a look at how to do that. This is a regular binomial expansion problem. You just expand the bracket so you get this red expression right there, which can also be rewritten as the blue expression right there. So moving on to B. Question B requires us to use the formula of limits to show that the derivative of this function f of x equals x cubed minus 4x plus 1 differentiates to 3x squared minus 4. So let's take a look at how to do that. So since f of x equals x cubed minus 4x plus 1, f of x plus h, which is the first term in my formula, shall equal the same exact function right there, but instead of each x we shall insert an x plus h. So instead of this x cubed we shall insert x plus h all cubed, and instead of the 4x we shall get 4 times x plus h. So for x plus h all cubed, this has already been found in question A right there. So we shall just copy this down, and then 4 times x plus h, and bear in mind that the 4 is negative, gives us negative 4x and negative 4h, and the plus 1 remains as is. So this is the evaluation of f of x plus h, and I've rewritten it right there. So this blue expression is exactly the same as this orange expression right there. The next term to evaluate is f of x, so minus f of x. Bear in mind that this minus right there shall affect the f of x. So I have inserted the negative sign as it is, and then I've inserted f of x in between brackets, knowing that the negative sign shall affect each term inside these brackets. So the brackets here are extremely important. So f of x, of course, is the black function right there, which I've inserted as is between brackets right here, and the h in the denominator remains as is. So the next step is to distribute the negative sign over the second bracket. So you get negative x cubed plus 4x, so the sign changes, and negative 1. Then the third step is to simplify the like terms. So we have an x cubed right there and a negative x cubed right there. So these cancel out together. So let's cross these out. Then we have 3x squared h, which has no similar term to it. So we just write this down as it is. So this goes down there. 3xh squared also goes down there. H cubed also goes down there. Negative 4x cancels out with the positive 4x, and the 1 cancels out with the negative 1. As for the negative 4h, it goes down there as it is. So after simplifying, we get this green expression right there. Next, we take out h as a common factor, since all the terms in the numerator have at least h power 1 in them. So we take out an h, and this is what remains after factoring out the h. Finally, we cancel out an h from the numerator with another h from the denominator. So this h cancels out with this h, and you are left with this expression right there, which I've rewritten in red. So I need to evaluate this expression as h approaches 0. So 3x squared shall remain as is, there is no h. However, 3xh is cancelled out because the h is 0, h squared is cancelled out because the h is 0, and the negative 4 remains as is, and I end up with 3x squared minus 4, which is the derivative of this black function, and this is what I was required to show. So moving on to question C. Question C says that the tangent to the curve of f at the point P1, negative 2 is parallel to the tangent at a point Q. Find the coordinates of Q. So let's take a look. So the tangent to the curve at P has a slope which we shall call M tangent at P, and this is the same as the slope of the tangent at the point where x equals 1, because at P x equals 1. So we want to evaluate f dash of 1 because we know that f dash of x is the equation of the slope. So if we insert 1 into this equation, we shall get the slope at x equals 1. We have already obtained f dash of x in the previous question as 3x squared minus 4. So we shall just plug a 1 into this formula, getting 3 times 1 squared minus 4, which gives us negative 1. Hence, the slope of the tangent at P is negative 1. Since we are told that the two lines are parallel, hence the slope of the tangent at Q is the same as the slope of the tangent at P, which is negative 1. So we know that the value of x at Q is found by solving f dash of x equals negative 1, because this is a point where the slope is negative 1. So we simply solve this equation, equaling it to negative 1, and attempt to find the x values. I've done just that, and the x values turned out to be either 1 or negative 1. Since we know that there are 2 points at which the slope is negative 1, and these are P and Q, obviously the x value at Q shall be negative 1, because at P the x value is 1. So this value is the x value of P, then this value has to be the x value of Q, and these are 2 points where f dash of x equals negative 1. Hence, having obtained the x value of Q, I can easily get the y value of Q by substituting negative 1 into the original function. So f of negative 1 has been evaluated, and I obtained the y value, which is 4. Hence, the coordinates of point Q are negative 1 and 4. So let's take a look at D. So D says that the graph of f is decreasing for P less than x less than Q, and I'm required to find P and Q. Let's take a look. Since f is decreasing, hence f dash is negative, which means that f dash is less than 0. So I just set this function as less than 0, and I attempt to find the x values. So the x values are negative 1.15 or negative root 4 over 3 and positive root 4 over 3. Since this is a less than sign, so I set them out in this inequality, as you can see right there. Finally, the range of values of the gradient is the range of values of f dash, which is this function. Since x squared is 0 or more, hence this function is negative 4 or more. So I hope you found this easy to understand. Take a look at the answer, copy it down, and we're done.